Okay, so we're just sort of reviewing light today. You did a worksheet on transparent, translucent, and opaque, and now I'm going to read a passage with you, and then you've got some questions to answer. I will make this passage available for you so that way you can see it, and then and then you can answer the questions, and you'll have a light exit ticket, and then hopefully tomorrow you are ready to take the light assessment. Okay, so this is a little long, so bear with me. Light energy. Energy is all around us. Energy can be classified as potential or kinetic. Potential energy is stored energy. Kinetic energy is moving energy. There are many types of potential and kinetic energies. Light is a type of kinetic energy because light energy is always moving. Light energy is a small part of a broader category called electromagnetic energy. Electromagnetic energy is a combination of electrical and magnetic waves. Electromagnetic energy includes the entire electromagnetic spectrum from radio waves, right there, to gamma waves. Humans can only see a small portion of the electromagnetic spectrum called visible light. Visible light is made up of all the colors of the rainbow. The wavelength of light determines color. Violet has the shortest wavelength, and red has the longest wavelength in the visible light spectrum. So if you see there, it really shows you how long the red wavelength is compared to the violet. Across the electromagnetic spectrum, wavelengths determines energy. The shorter the wavelength, the more energy a wave has. For example, gamma rays have the shortest wavelengths, and they have the most energy. Radio waves have the longest wavelengths and the least energy. Waves with a lot of energy are harmful to humans and other animals. Gamma rays, X-rays, and ultraviolet rays can damage the cells of the body and cause intermediate trauma or lead to cancers. Conversely, low energy waves such as radio waves are not usually dangerous for humans or animals. The sun releases most of the electromagnetic energy on Earth, but light bulbs and fires also put out, electromagnetic radiation. However, light bulbs and fires release much less energy than the sun because they aren't as hot. As a result, light bulbs do not release gamma rays or X-rays, but they do release ultraviolet rays, visible light waves, and radio waves. One of the reasons light bulbs are inefficient is they release extra energy as heat and electromagnetic waves we cannot see. Light, or electromagnetic energy, is the only energy we can see. It is also the only energy that can travel through space. All other types of energy require atoms or molecules. Light energy from the sun is released through nuclear fusion from two hydrogen atoms combined to form a helium ion. Light energy travels outward from the sun at an incredible 300,000 kilometers per second. Light is the fastest thing in the universe. Remember that it takes the light 8.5 minutes to get to us for us to be able to see it. Nuclear energy is converted into electromagnetic energy when two hydrogen ions combine to form a helium ion on the sun. Light energy is made up of photons. Photons are tiny individual packets of light energy. Every wave on the electromagnetic spectrum is made up of photons. Photons are particles, but light acts like a wave. Scientists didn't know if light was a particle or a wave until Albert Einstein determined it was both. Light energy is both a particle and a wave. When photons hit objects on Earth, they make the electrons in the atoms jump. The light energy is converted into thermal energy. The increased thermal energy makes objects feel warmer. Light energy affects almost every part of nature. Light energy heats the Earth unevenly. The equator gets the most direct sunlight, so it is warmer than the North and South poles. Dark areas of the Earth absorb more sunlight than light areas, so they are warmer too. This uneven heating drives wind and ocean currents. Light energy is also part of the water cycle. Sunlight heats liquid water molecules until they become water vapor. This process is called evaporation. So there's the water cycle. Light energy provides plants with energy for photosynthesis. Without plants, animals on Earth would have nothing to eat. Plants also produce the oxygen as we breathe as a byproduct of photosynthesis. So we talked about photosynthesis before. So the sunlight comes down and the plants, the leafy part of the plant uses that, and the carbon dioxide that we breathe out, they use that in the sunlight to create sugar, and that's what they use to get their energy from. And when they make photosynthesis, the gas they produce is oxygen, so it's a win-win for both of us. All right, humans have also learned to convert light energy into electrical energy through solar panels. Light energy is a clean, renewable energy because it doesn't release any pollution, and it is continually provided by the sun. Solar panels are being improved to be a more efficient and cost-effective. Special batteries also have been invented, so light energy can be stored and used at night when it is cloudy. Without light energy, we could not live on Earth. Other types of electromagnetic energy do important jobs on Earth as well. For example, flowers have ultraviolet patterns on their petals that show bees where to land to collect nectar. These patterns are invisible to humans because we cannot see within the ultraviolet part of the electromagnetic spectrum, but bees can. As we learn more about the world around us, we learn more about the ways light energy and all electromagnetic energy affects on the Earth. Okay, so you're going to have 5 questions, and you're going to answer light energy is. Go back into the passage and answer that. And then you'll have those right there. All right, bye.